Let's take a look at using bond energies to determine the enthalpy change of a reaction. Or in this case, we're asked for the molar enthalpy. So to get the molar enthalpy, we know we have to first get our enthalpy change, and then we can divide it by the coefficient in front of my entity. So when we're looking at using average bond energies to determine the enthalpy change for a reaction, the first thing we need to do is we need to look at our Lewis structure or structural diagram of all of the entities that are present. Once I have this, then I know what types of bonds that I have and what atoms are bonded to which, so I can go and look up bond. So here I can see the energy of all of the different types of bonds that are present in my compound. Okay. And then now what I can do is I can go and start looking at the energy associated with it. So here I have 5 carbon to hydrogen bonds, because I have 1, 2, 3, 4, 5 carbon to hydrogen bonds times the average bond energy for a carbon hydrogen bond. Then I have 1 carbon to oxygen bond, so 1 times the average energy of carbon to oxygen bond. 1 oxygen to hydrogen bond, 1 carbon to carbon bond, and then I have 3, because I have 3 O2s, oxygen double bonds, so it's energy. So I find that it takes this 4,722 kilojoules to break all the bonds in my reactants. Okay, and then I can likewise take the structure of my products and I can determine the energy in their bonds. So I have 2 carbon oxides that were formed, so each carbon oxide has 1 carbon to oxygen bond, so that gives me a total of 4 times the energy of a carbon double bonded to an oxygen. And then I have 3 waters that each have 2 oxygen to hydrogen bonds, so that gives me 6 oxygen to hydrogen bonds times this energy, and it tells me I have that much. So therefore we know the enthalpy change is the energy of my reactants minus the energy of my products. So what we get is we get negative 1,060 kilojoules. Okay, now this is an enthalpy change. This is the energy change for this balanced chemical reaction. It's an enthalpy change. To get a molar enthalpy, I have to take my enthalpy change and divide it by number of moles. And this, since this reaction was balanced based on 1 mole of the reactant, I would take that enthalpy change divided by 1 mole, and I get my enthalpy change for my reaction. My molar enthalpy of combustion.